Okay, a video now on something called the highest common factor, or the HCF. In a question on the exam paper, you may well be given two numbers. So for example, question number 1, the numbers 36 and 54, and you'll be asked to work out the highest common factor of these numbers. The method is very straightforward. I'll go through the technique, then I'll explain how we get the HCF at the end. What you do is, you take the first number, 36, and we use the tree sketch method to express 36 as a product of prime factors. So, just like in the last video, we set up a tree sketch. So I know from my times tables, for example, that 6 6s are 36. I mean, I could use 4 9s, for example. I could use 3 12s. But 6 6s will work. So 6 times 6 is 36. 6 is not a prime number, so split it up again. 2 3s make 6. 2 is a prime number, 3 is a prime number, so I circle them. 6, same thing, 2 3s. 2 is a prime number, 3 is a prime number. So we end up with 36 being equal to 2 times 2 times 3 times 3. Now for the purposes of doing HCF work, I don't need to write this in index form. Next, we take the 54 and we do exactly the same process. So 54 splits up into, well, 2 would work times 27, but if you know your tables, you might prefer to use 9 6s, which is what I'm going to do. 9 6s are 54. 9 is not a prime number, split up into 3 3s. Both 3 and 3 are prime numbers. 6 is not a prime number, so we split it up. 2 3s are 6s. 2 and 3 are prime numbers. So I can see in this particular question that 54 is the same as 2 times 3 times 3 times 3. Now, these are in maths known as factors of 36, and if you multiply all these factors together, they give the answer 36. These are the factors of 54. If you multiply all the factors of 54 together, you get the answer 54. And if you want the highest common factor, well, common means what is in both. What factors are in both? And we want the highest factor in both. Well, let me just show you what I mean. For example, I can see there's a 2 and a 2 in both. So 2 is common to both. I can also see there's a 3 and a 3 in both. And I can also see there's another 3 and another 3 in both. So I can see in both of these, common to both, is 2 times 3 times 3. 2 times 3 times 3. So when I want to work out the highest common factor will simply be 2 times 3 times 3. And 2 times 3 is 6, 6 times 3 is 18. So that is what we know in maths as the highest common factor. It's the number that if you take 36 and if you divide it by 18, gives you a nice answer. If you take 54 and divide by 18, you get a nice answer. And you simply get it by taking those three circle values and multiplying them all together. That is known as the highest common factor. It's the highest number that is common to both. Let me show you with number 2. Okay, so I'm going to move this up slightly. 30 and 100. 30. I'm going to do 3 10s. 3 is a prime number, circle it. 10 is not. 2 5s are 10. 2 is a prime, 5s are a prime. So we can say that 30 is the same as 2 times 3 times 5. So we've got that there. Okay, let's do the same thing for 100. 100 is the same as 10 10s. 10's not a prime number, split it up. 2 5s. They are prime numbers. 10 is 2 5s. They are prime numbers. So 100 is the same as 2 times 2 times 5 times 5. There's 100 as a product of its prime factors. Now all you've got to do is find out what numbers are common to both. Well, I can see there's a 2 in both. There's no 3 in both, but there is a single 5 in both. So that means that the highest common factor will be the 2 times by the 5. So 10 is the highest common factor. That means the biggest number you can divide 30 by and you can divide 100 by. You can divide them both by 10. And that comes from the 2 times 5. Right, number 3. 120. 12 tens. 12 is 3 fours. 3 is a prime number, 4 is not. 2 twos. 10 is not a prime number. 2 times 5 is 10. Both of those are primes. So 120 is the same as, we've got 1, 2, 3 twos. 2 times 2 times 2 times, and we've got a 3 and we've got a 5. Like so. So there you go. There is product of prime factors for 120. Let's do the same thing for 300. 300, 30 times 10. 30 is 5 sixes. 5 is a prime number. 6 isn't. 2 threes are 6, so 2 and 3, prime numbers. 10's not. 2 fives are 10. 2 and 5 are prime numbers. So we end up with 300 being equal to 2 and 2, 2 times 2, times a 3, and then we got another 2 fives. So times 5 times 5. So there you go, there's 300. Let's have a look at these two now. Which are values common to both? Well, I can see a 2 times 2 in both. 2 times 2 is in both. And I can see a 3 times a 5 in both. 3 and a 5. 3 and a 5 are in both. So that means that the highest common factor will be 2 times 2 times 3 times 5, because these four values are in both of these expressions. 2 times 2 is 4, 4 times 3 is 12, 12 fives are 60. So the highest common factor is 60. That means the biggest number that will go into 120, and it's also the biggest number that goes into 300. So the HCF is 60. Okay, number 4, if I move this up. Number 4, 216. Okay, a bit harder. I know that 2 times 108 is 216. 2 is a prime number. I know that 2 times 54 is 108. 2 is a prime number. I know 9 sixes are 54. 9's not a prime number, so carry on. 3 threes are 9. Circle, circle. Like so. 6 is not a prime number. 2 threes are 6. Circle, circle. So 216 is 1, 2, there's 3 2's there. 2 times 2 times 2 times, and there's 1, 2, 3 3's. 3 times 3 times 3. So there you go, there is 216 as a product of prime factors. Let's do the same thing with 308. 308. Okay, well, 2 times 154, you could do a side box division if you couldn't do that in your head. 2 times 154 is 308. 2 is a prime number. Okay, this one here, 2 times 77. Okay, again, you could do a box division, 154, box division 2, and you get the answer 77. 2 is a prime number, 77 isn't, but I do know in my tables now, 7 11s are 77. 7 is a prime number, so is 11. So 308 is 2 times 2 times 7 times 11. Okay, that's 308 as a product of its prime factors. Right, what is common to both? Well, I can see a 2 times a 2, 2 times a 2, and I can see that 7 and 11 are not in this one at all. So the only thing that is common to both is 2 times 2. So the HCF is 2 times 2, which is 4 for this question. So the HCF of those two numbers is the number 4. That's the biggest number that will go into that, and it will also go into that. Very last one, let's do it quickly then. 140. So 140 is going to be 140, splits it up into 14 times 10. 14 goes to 2 sevens, prime number, prime number. 10 is 2 fives, prime number, prime number. So we have that 140 is 2 times 2 times 5 times 7. That's the product of prime factors. 1050 is a bit harder, but because it ends in a 10, I know it's 105 times 10. 105, well, I know if you say 5 times 21, 5 times the 20 is 100, 5 times the 1 is 5, so it gives 105. You could do a box division if you want. That's a prime number. 21 is 3 sevens, prime number, prime number. 10 is not a prime number, 2 fives are 10, prime number, prime number. So 1050 is 2, there's only one of them, times 3, there's only one of them, times at 2 5s, so a 5 and another 5, and then we've got a 7. So there's 1050 as a product of prime factors. Let's now do the HCF. The HCF is the values that are common to both. There's a 2 in both, a 2, no 3 in both, notice. There's a 5 in both, and there's a 7 in both. So the HCF will be 2 times the 5 times the 7. 2 5s are 10, times 7, 70 is the highest common factor of 140 and 1050. And that's the end of this video.